Current electricity. Section B. Combination of resistors. To have a desired resistance in a circuit, sometimes we have to connect two or more resistors together. They can be combined in three ways: in series, in parallel, the combination of series and parallel. In the series connection, the resistors R1, R2, R3 and R4. They are joined back to back, that is one behind the other. In a parallel combination, the resistors are connected parallel to each other. When it comes to the combination of series and parallel, in this circuit diagram, resistors R2 and R3 are parallel and they are connected in series with R1 and R4. So we are going to solve some numericals based on various combinations like this. Resistors in series. In this circuit diagram, we have a battery and two resistors R1 and R2 connected in series. The current I flows from the positive terminal of the battery. It passes through R1 and R2 and reaches the negative terminal of the battery. So current has a single path for its flow, and the same current I passes through each resistor. In this circuit diagram, there are four resistors connected in series. The potential difference across the resistor R1 is V1. The potential difference across R2 is V2. Across R3 it's V3 and across R4 it is V4. Potential difference across any resistor is directly proportional to its resistance. So the potential difference is different across the different resistors. More the resistance, more the potential difference across that resistor. The potential difference across the entire circuit is equal to the sum of the potential differences across the individual resistor. That is, V is equal to V1 plus V2 plus V3 and it goes on. In this circuit diagram, there are three resistors R1, R2 and R3 connected in series. The sum of all the resistance values gives the equivalent resistance. We have Rs, that is the equivalent resistance of this combination, series combination, to be equal to the sum of the resistances of the individual resistors. So Rs is equal to R1 plus R2 plus R3. In the series combination, the equivalent resistance is equal to the sum of the individual resistances. Resistors in parallel. Here, there are two resistors R1 and R2 connected in parallel. The potential difference across each resistor is same, that is equal to the potential difference across the terminals of the battery. If V is the potential difference across the terminal of the battery, V will be the potential difference across each resistor. In this circuit, the current flows from the positive terminal of the battery, and once it reaches this point, it is divided into I1, I2 and I3. So the current in a resistor is inversely proportional to its resistance. More the resistance, less amount of current passes through that resistor. So here we can see the current is divided into I1, I2 and I3, and the amount of current that flows through each resistor, it depends on its resistance value. So I is equal to I1 plus I2 plus I3 plus it goes on. In the parallel combination, the reciprocal of the equivalent resistance is equal to the sum of the reciprocal of the individual resistors. That is, 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula we're going to use while solving the numericals. Recap. In the series connection, when the resistors are connected in series, the equivalent resistance, that is denoted by Rs, is equal to R1 plus R2 plus R3. That is, the equivalent resistance in the series combination is equal to the sum of the individual resistances. In series connection, same current I passes through each resistor. The potential difference is different across different resistors. When the resistors are connected in parallel, the equivalent resistance, that is denoted by Rp, it is equal to 1 by R1 plus 1 by R2 plus 1 by R3 minus 1. The potential difference across each resistor is same. Current I is divided depending on the resistance of the resistors. In the parallel combination, the equivalent resistance Rp is less than even the smallest resistance connected. Here, two resistors connected in parallel. We have 1 by Rp equal to 1 by R1 plus 1 by R2. Taking the LCM, we have 1 by Rp is equal to R1 plus R2 divided by R1 R2, and this gives us Rp to be equal to R1 R2 divided by R1 plus R2. So we are going to solve numericals based on various combinations of series and parallel connection.